Hello, good day everyone. Welcome to another mathematics tutorial. In this video, I'm going to discuss to you the first lesson in mathematics grade 10. The title of the lesson is Finding the Terms of the Sequence. Before we start, kindly prepare your notebook and your ball pen. Patterns are all around us. So there are so many patterns that we could find everywhere. So it can be shapes, colors, and even numbers. So here we have an example of a pattern. So this is a number. As you can see, there is a number line. So start from 0, 1 up to 10. And we have here 1. 1 is the first number. All right. And we have an arrow here that 1 jumps to 4. Okay. And 4 jumps to 7 and 7 jumps to 10. So this is an example of a pattern. Why? Because this pattern starts from 1 and jumps 3 every time. So from 1 we count 3 units. So 1, 2, 3. And from 4, 3 units again. 1, 2, 3. And from 7, 1, 2, 3. So there is a pattern. So we all know that from 10, we will count 3 units from 10. So it becomes 13 and so on and so forth. So this is an example of a number pattern. We have also another example here. We have 4, 8, 12, 16, and 20. Can you think of a number that will be added to 4? It became 8. All right, very good. That is 4. Okay, from 4, we jumped 4 every time. So 4 plus 4 is 8. 8 plus 8 gives us 12. 12 plus 4, 16. 16 plus 4, 20. And from 20, we all know the pattern that we are adding 4 every number. All right. And as we analyze these two examples, that two examples are in increasing order, right? So we add up a certain number to each of these numbers here. So in this example, we add 3 every time. And for this another example, we add 4 every time. Okay, so let's proceed to what is a sequence. Here is a definition of a sequence. A sequence is a list of things, usually numbers, that are in order. So here an example: 4, 8, 12, 16, and 20. So this is a sequence of numbers, right? So they are written in order, increasing order. And from the previous slide that I showed you, that this is also a pattern. Why? Because we add 4 every time. So in this particular example, since this is an example of a sequence, because they are written in order, the first term here is 4. 8 is called the second term. 12 is called the third term. 16 is called the fourth term. And 20 is the fifth term. Each number in the sequence is called term. So if there are 100 numbers in a sequence, so the last number is the 100th term. Okay, so let's proceed. There is a rule that we follow in a sequence. We don't just write any numbers and call it a sequence. In a sequence, we use a rule. A sequence usually has a rule, which is a way to find the value of each term. Example, sequence 3, 5, 7, and 9 starts at 3 and jumps 2 every time. So this is an example of a rule. Okay, jumps every time, or we are adding 2 every time. So in this particular example, this plus 2 here in each number, so this is the rule that we follow, because after 9 we add 2, so it becomes 11. We add 2 again, so that is an example of a rule. Now here is a particular problem. It doesn't help us to find the 10th term, 100th term, and the nth term. In this particular example, 3, 5, 7, and 9 has only 4 terms. All right. So what if we are asked what is the 10th term? How about the 100th term? And how about the nth term? Nth term can be any number. So it is very difficult for us to um, identify the 10th term because we have only 4 term here, no? The 3, 5, 7, and 9. So what we are going to do is we are going to use a formula in finding the term. Okay, so before that, before solving, let's have a notation first. So this is a notation used in sequence. To make it easier to use rules, we often use this special style. All right. So the symbol here is read as a sub n. All right. A sub n. There is a letter here, n, which is written under a. So it is read as a sub n. Okay. And n here is the term number. Okay. A sub n is the term and n is the term. Okay, we're lacking here. Is the term number. Okay, let's have the example. So the first term, okay, a sub 1, that is the term, right? So this is the first term. Okay, first term. And it can be read as a sub 1. So that is the first term of the sequence. We have here a sub 2. Okay, this is the second term of the sequence. A sub 3, the third term of the sequence. A sub 4 is the fourth term of the sequence. Okay, again, so the number written below the letter A here is the term number. So, and the whole symbol is the term. So what is that term? So let's have an example. Next, we're going to determine if a given sequence is finite sequence or infinite sequence. So finite sequence, a sequence with a specific set of numbers. So we can count the number of term in that sequence. However, infinite sequence is a sequence that is endless. Meaning to say we cannot count the number of terms in that sequence. So for example, 10, 12, 14, 16, 18. Is this a finite sequence or infinite sequence? The answer for this is finite sequence because the first term is 10 and the last term is 18. So we can count the number of terms. So there are 1, 2, 3, 4, and 5. Okay. However, in this example, 10, 12, 14, 16, 18, and we have the dot, dot, dot. This dot, dot here will tell us that this sequence is still going on, meaning it is endless. So this is an example of an infinite sequence. Writing the first terms of a sequence. So this is the particular topic that I tell you a while ago, that how about we are going to find the term number or the term. Okay, example, write the first 5 terms of the sequence whose nth term is given by a sub n equals 2n plus 1. So nth term here is that it can be n here is can be any number. Okay, and it's given by the formula. So this is the formula of the sequence. Formula of the sequence. Okay, so there are many terms that we can derive in this formula, but we are asked to write the first 5 terms. Meaning to say that we're going to find a sub 1, we have a sub 2, a sub 3, a sub 4, and a sub 5. So these are the terms that we are going to solve. So here are the solution. Okay, so since we are going to find the 5 terms, so the term number 1 given by a sub 1. So what we're going to do is to substitute 1 in this formula. Substitute natin sa value na n. So we have here a sub 1. Substitute natin again sa value ng n. So we have 2 times 1 plus 1. It gives us 3. Okay, for the second term, a sub 2. Okay, tapos ng a sub 1, right? So that is second term na natin. So yung term ng a sub 2, substitute natin yung value ng 2. So a sub 2 equals 2 times 2 plus 1 is 5. For the a sub 3 naman, substitute natin yung value ng 3. So 2 times 3 plus 1 is 7. A sub 4, 2 times 4 plus 1 equals 9. And a sub 5, okay, 2 times 5 plus 1 equals 11. Okay, so these are the 5 terms in this sequence. To check whether your sequence is correct, so let us examine if may rule ba siya na may rule ba siya. So from 3 naging 5, meaning to say we add 2. So dapat yung rule niya is plus 2. So 5 to 7 plus 2, 7 plus 9 is plus 2, 9 plus 11 plus, all right. So this terms that we're able to solve is an example of sequence. So therefore, our answer is correct. So therefore, the first 5 terms of the sequence a sub n equals 2n plus 1 are 3, 5, 7, 9, and 11. All right. So it's very clear and it's quite easy. Okay. How about we're going to find the term? So as what I've said a while ago, that in this expression a sub n here is the term. Okay. And n here is the term number. So it is the placement. Okay. So in this particular example, what is the 10th term of the sequence defined by the formula below? A sub n equals n squared plus n minus 1. So meaning to say, in this solution, we are going to find the n equals 10, which is a sub n. Alright? So, kailangan natin malaman kung ano ang value ng a sub 10. Okay. So a sub n equals n squared plus n minus 1. So it becomes yung n, this is n, term number. So that's what I've said to you before. Here, n is the term number. So term number is 10. So substitute natin. A sub 10 equals yung n magiging 10 squared plus 10 minus 1 na. So it gives us 10 squared is 100 and 10 minus 1, this 100 plus 9. So a sub 10 is equal to 109. Therefore, the 10th term of the sequence given by a sub n equals n squared plus n minus 1 is 109. Let's have more examples. Example number 3. Which term of the sequence is given by a sub n equals 3n minus 6 is 42? Solution. Given that a sub n is 42. So, alam naman natin, no? So, as what I've said before, that in the expression a sub n, this is the term. And the n here is called the term number. Okay. So, since the question, which term of the sequence given by a sub n, 3n minus 6 is 42. So, meaning to say, a sub n niya is 42. Tapos, hahanapin natin kung ano ang value ng n. Alright. So, a sub n, this is the formula, equals 3n minus 6. So, yung a sub n natin, substitute natin ng 42, tsaka yung n natin, this is what we're going to solve. So, 3n minus 6. And, by you're going to transpose this or combine like terms. To combine like terms, yung minus 6 transpose natin sa left side. So, magiging 42 plus 6 na siya kasi minus dito. And equals, so natitira na lang yung 3n. So, 42 plus 6. So, here, medyo you have a mistake here. So, dapat 42 plus 6 will give us 48. Alright. Equals 3n. So, dapat nag-plus pa tayo. Nag-plus tayo. So, this is 48. So, divide natin to ng 3. Divide natin ng 3. Alright. So, it became 48 divided by 3 will give us 16. So, meaning to say that the nth term is 16. So, dapat 48 to. Okay? So, 16 is equal n, or n equals 16. So, therefore, 42 is the 16th term of the sequence. A sub n equals 3n minus 6. Alright, so let's have the generalization. So, let's sum it up. In this module, you have learned that so a sequence is a function whose domain is the finite set or the infinite set. So sequence can be finite and infinite. A sequence is a finite sequence if it has a last term. A sequence is an infinite sequence. It has no last term. So, so what I've said in this particular example, no, kita natin. So it is endless. Here, meron siyang symbol na ellipses that is still 1, 2, 3, that this sequence is still going on, but we observe that it has a last term which is n compared to this one. Okay. Number 3, a sequence is usually given by stating the general rule or its n term. Hence, we can find its new few terms. So, as what I've said, there is a general rule. Merong rule na ginagamit in a sequence so that we can find the nth term of the sequence, because if it's not following the rule, then it is not a sequence and it is difficult for us to find what will be the next terms. Number 4, you can find the difference terms of the sequence by substituting the value of n in the nth term of the sequence and simplifying it. So in this particular example natin, so what we discuss, so we substitute the value of n or the a sub n so that we are able to find what is the term number or the term. Okay, so this is for the first lesson in grade 10 mathematics about generating patterns, and I hope that you will check my next videos on next lesson. Thank you so much for listening and have a good day.